So hello everyone, welcome to Triad Pack 365. So myself Sujit. So today in this session we are going to complete our part 2 of our means the part 2 of our variable chapter. Okay. So in previous session we are going to see how to create a variable, then what is token, then what is identifier. Okay. For in this session now we are going to discuss if we are going to create a variable in the memory, how it will going to assign and how it will going to create each and everything in this session we are going to complete. Okay. So guys, till now, if you have any doubt, you can directly reach to trywrite.com. Okay. Then in Python, in this Python memory management, in Python have two memory. Okay. Python have two memory to manage this variable and everything. Okay, to memory. First one is stack memory. Okay, first one is stack memory, and second one is heap memory. Okay, so how both are going to use, now we are going to see. So guys, heap memory means if we are taking an example of a equal to 10. Okay, just for an example means we are creating a variable called a, and in a we are assigning a value of 10. Okay, means in the simple word you can just tell that, but in how the Python is going to take both of these means it will be take means if I take calling that stack memory means stack always store it store means stack store function call and the object reference. Okay, as of now we don't complete this function called, okay, in the upcoming session, but we are complete this function called and object reference. Okay, so guys, just see a, it will be storing this 10 means it will be storing the reference of this object. In Python everything it will be treated as a object, guys. Okay, so now if I'm telling that a it will be storing a object means a will be stored in our stack memory. Okay, stack first in last output. Okay, means storing in first and out in, okay, last. Okay, then what is the use of this heap memory, guys? Heap memory, guys, always store the actual value. Actual value when stored in heap memory. Okay, means if I taking a, it is a variable, but it will be storing this object, but the value will be 10, guys. So 10 it will be stored in our heap memory and a will be stored in our stack memory. Okay, so make sure that you need to understand stack always store the object reference and the function called, and this heap memory it always take the actual value of an object. Now guys, if I'm taking an example, okay, guys, I will create a variable called a equal to 10. Now my requirement will be I want to create a variable same means the previous variable, and I need to update that particular value means now a equal to 10, but now I want a equal to 20. Now if I want to print a in Python, it will be taking or printing 20. Why? Because in Python memory management, there are two concepts. Okay, one is reference counting and one is garbage collection. How both are going to work, we're going to see. So guys, we know in Python, each and everything, it will be create a memory location. Means if you are going to create a, it will be stored in a memory location. Means a, it will not create that particular memory location. 10 will be created. If you want to check that particular thing, we have a id function. In the previous session already I have talked about that. Okay, told that particular thing. Now if I'm going to print this a means that id, if you can see, it will be referred to different memory location. Guys, just see Why? Because 10 it will be creating for one memory location and 20 it will be referred to one memory location. But the both the variable name will be shared. But in Python, this is how complete means. In Python we can say that whenever you want to create a variable, at a time variable only take one value. Okay, if we are giving multiple value, just see guys, we are giving multiple value for one. Okay, at that time it will be remove that old value and replaced with this new value. Okay, so this is a point. Okay, they might be ask you this in interview. Okay, so any variable can take only one value at a time. Okay, if we try to give multiple value or duplicate value, multiple value, then the old value shall be replaced. Okay, replaced with the new value. Okay, how it going to work in a means this is for your user understanding, but how in the backend we are going to see means I have a new example based on that we are going to deal. Can I just see for a new example? Okay, for both point we are going to discuss that zero means that object reference counting and that particular garbage collection. Guys, if I'm creating a equal to 10, okay, now again I just want to create c equal to also 10 means for this 10 it will be creating one memory location. Again for this 10 it will be creating, guys? No, it will be not creating, guys. If you want to check that particular thing, both are pointing to a same memory location, guys. Why? Because in Python whenever you are going to create multiple variable but the same value, then their memory location shall be shared. Just guys see, both are refers to this one memory location. So how it going to work, we are going to see now through an example. So I'll give you that point, then we are going to see. So we can say if any variable having variable, okay, having same value, okay, having the same value, then their memory location will be shared. Okay, means we can say no new memory will create. Why? Because in Python, each and everything it will be created for one that particular object. Okay, that's why it will be not creating any new memory. It will be referred means that memory location shall be shared. Just guys see for this example that two memory it will be pointing to one value. That's why the memory will be shared. Now we are going to see an example. Guys, just see. I'll create x equal to 6, y equal to 5 and z equal to 5. Okay, how it going to happen means how the stack and heap will going to work. So we know that stack it will be always store function and reference object, and heap it will be storing actual value. Guys, just see, now I am creating z equal to 5 and y equal to also 5. Means in Python we know that they both are particularly share that memory. Means this will be not even created. Means both are referred to this one memory location. Okay, and how guys this will going to work means whenever takes x equal to 6, x will be stored in stack memory and the actual value will be stored in the heap memory. Okay, now how then we are going to see that particular reference counting and our garbage collection? Now we are going to see. Guys, just see, this is a memory, means I'll taking 5 variables, okay? Means in this memory, we can explain that particular things, okay? How the garbage location, how the reference counting will going to work. So guys, I think I will be explaining reference counting and that garbage collection. Then we are going to discuss this example, okay? Then you can get a clear picture on that, okay? So then also if I'm providing the note, it will be more useful for you. Means after 10 days, 5 days, might be you can forget. But if you are just looking this notes or video, you can get, okay, so this is how this memory will going to create. Okay, so guys, first we are going to see what is reference counting. Okay, guys, if you are seeing also here this memory, it will be gone. Means if you are creating for this new value, this memory will be gone. Based on that, this is refers to, means as of now it will be not referred to anywhere because a will be not there. That's why this is called your reference counting. Means in Python it will be use a technique, okay, reference counting. Okay, means this is a technique, guys. Or think about that. Okay, so what is this work of this reference counting? It will be counting the each object reference. Means if we're creating here, guys, just see, if I'm creating 10 and 20, means Python always check that this object it will be referred to anywhere or not. If they will be not referred to anywhere, okay, means in this case it will be not referred to anywhere, guys. Means Python automatically it will be treated as reference counting as 0. Once Python will be refer as reference counting 0, then the garbage collection will go to work. Means garbage collection, it will be deleting the unused value. Means this is unused, guys. Okay, so garbage location it going to work like that. Okay, means first your Python automatically check this object it will refers to anywhere or not. If not, it will be treated as a 0 reference counting or reference counting equal to 0. Then Python automatically take that into garbage collection because the work of garbage collection is if it will be not used or not referred to anywhere, it will be collect that memory, it will be delete. Okay, so I'll gives you that point. Okay, Python uses a technique called reference counting. Okay, where each object means everything it will be treated as an object. Keep track of the number of reference pointing to its, means it's always checking it will be pointing to any object or not. If you are guys seeing here, it will be not referred to anywhere, guys. Means a it will be storing this object reference, guys. Okay, just like that. Then here when an object refers count reaches to 0, okay, Python automatically deallocate, means delete, or we can say that treated as this memory as a deallocation or reverse counting 0. Then after this will be happen, then our garbage collection will going to work. So I'll give you that particular definition, then we are going to see that particular example. Okay, so garbage collection. What is garbage collection, guys? If it is used to delete the memory that is unused in the main memory. Okay, so this is called our garbage collection. Okay, so then this garbage collection have some demerits. Okay, means what is this demerit, guys? means deleting the memory before compilation. Means if our guys see, even if we are not even printing that particular thing, now if I'm printing, it's automatically delete. So this is our drawbacks also. Okay. So then, guys, I just want to give you one more clarification. Okay, means how both are going to work. Means garbage collection and this reference counting, how it going to work by the help of this Python memory management. Okay, so Python memory, it will be taking that reference counting and also this garbage collection. So this is how this Python memory is going to work. Now we are going to see in this example. I just say, I just take a equal to 10. So I'll create a memory location for this 10 and I will be assigned a object or object reference called a. So guys, I'll take this one. Okay. So here I just want to take a. Now means a, it will be referred to this, and for this one I'll be passing a memory location. Okay. Means for this one. Now then b equal to 20, guys, means for 20 it will be creating one memory location, and that particular memory or variable name should be b, and it also refer to one memory location. Okay. Now again c equal to 30, means for this 30 again one memory will be created, and for this memory the object reference should be c, and for this one memory location also this will be. Now guys, just see again, I just create d equal to 10, means already 10 will be created, means it will be not creating a new memory, because here we are already seen no memory will be created if you are going to share that particular. Means in this case here it will be share this particular things, means here it will be sharing the memory location, means a and d, it will be referred to one particular memory location. Then guys, again I just say b equal to 40, means we know that b, it will be refers to 20 object. Now I want to change this, means in Python memory management, this will delete this memory. Okay, this will be delete this 40, and for this 40 it will be creating a new value called our 40, means our 20 will be go to that garbage location. Okay, so in the real time also it will be do like that, means it will be checking that object reference. Guys, just see, now if you are going to give this 20, it will be referred to garbage location. Okay, garbage location means it will be directly done by this Python memory management. It will be set 40 as to be, and for this 20 it will be go to this garbage location. So this is how the Python memory will going to work, but we are no only to type that particular thing, but in the real time, or we can say in the backend, it will be just created like that. Okay, so if you have any doubt, you can directly ask to the try writes, and thanks for watching this session.